Hey everyone, and welcome to our lesson on investigating the graph of f of x equals x to the nth power. We're going to take a look at some functions that have powers, see what the pictures look like, and talk about some of the characteristics of those and some patterns that we see. So to start, let's take a look at the even-powered functions. If we are looking at something that has a power of 2 or 4 or 6 or so on x, what's going to happen is it's going to look sort of like a parabola that we're familiar with, but as the power increases, the graph is going to get wider. So if it hasn't been translated in any other way, if it's just the x to that power, it'll still occur on the origin here. It'll just become wider and wider as the power increases. So you can see here this shows the examples of the three of these here. As the power gets bigger, it gets wider and wider here at the bottom. Alright, and if you noticed on that other graph of the even powers, both ends were doing the same thing. But that's not going to be the case here. Here are the odd powers of x, and same thing's going to happen. As the power gets bigger, the graph's going to get a little bit wider around the origin area here and just spread out a little bit. And on the odd-powered functions, the ends are going to be doing different things. So one's going to be going up and one down. It won't necessarily always be the left one that's down, as these are, and the right ones that are up, but one will be doing one direction and one will be doing the other. Okay, so let's review these patterns again. As we look at these, just remember the higher the power, the wider the graph's going to be that you're going to see. Even powers are going to have the ends doing the same direction, whereas the odds are going to be doing different things. Alright, so when you take a look at these pictures, one important characteristic that we look at with a lot of graphs is the zeros or the roots, also known as x-intercepts, and that's going to be where this graph crosses the x-axis. To know how many you're going to be finding or how many the graph's going to have, you're going to look at the power. So we just looked at powers of x, 2 through 7. Depending on what power you see, that's how many zeros the function should have. So if you see, and it doesn't have to be just x to a power, it could have some other stuff in there which would make some translations. For instance, here's a cubic function. It's got some translations going on. But when I look at the power, it's a 3, so that means wherever this graph is, it's going to have 3 zeros, 3 roots. And if I see a different number there, wherever my x term is, I'm going to be looking for that and looking for that power, and that's going to tell me how many roots that one's going to have. So this one would have 8. Just a couple of examples there and what to look for. Some other things you're going to notice about these are that they have certain kinds of symmetry. Symmetry just means a place where the graph is nice and even and kind of reflects over itself. If you were to flip one side of it over, it would overlap the other side of itself. It's just symmetrical around a line. Even powered functions of x are going to be symmetrical around the y-axis. So remember, those were the ones that look like this. Okay. If you were to draw a line through the middle, it looks the same on one side as it does the other. Whereas the odd graphs that we took a look at, they are sort of nice and even, but they aren't the same on the left as they are on the right. Their point of symmetry is just that middle origin point. You'd have to reflect them a couple times to get them to overlap themselves on the other side. So they are symmetrical, but not around the y origin, not around the y-axis, just the origin. Alright, so we talked about what the ends are going to be doing on these power functions. The evens are both the same, and the odds are going to be doing something different on each end. And here's an example of, this is some odd powered function, maybe a cubic, maybe an x to the 3rd power. And on the left you can see that that end is going down and the right hand end of the function is going up. And we have a formal mathematical notation to state that end behavior. So we're going to take a look at that. Alright, so to state what's happening on the ends of that graph with formal mathematical notation, we're going to use this notation here. Remember the graph that we just looked at was left end down, right end up. So to state that in math notation, we're going to say as x approaches negative infinity, that represents the left, y approaches negative infinity, that represents this down direction on the left end. And on the right, as x approaches positive infinity, the function is moving up, positive infinity. And if you'll notice, left and down are going to be using negative infinity, where right and up will use positive. So that was an odd-powered positive function, this function here that we saw on this last slide. If we had an odd-powered negative function, it would be doing the opposite. So on the left end, it would be going up. So you can see that here. As it approaches negative infinity, the function moves up. And on the right end, it's moving down. So as x approaches positive infinity, the function is approaching negative infinity. And you can use this to describe no matter what power you have, every time that you have odd power, negative or positive. Same thing with the even-powered functions. But remember, those are going to be doing the same thing on both ends. The positives, no matter how many turns they have in the middle, they'll always be ending up both ends, whereas the negatives are both going to be going down. So we just use that same notation, but we'll have two positive infinity symbols for the y's. You can see that here. Whereas the negatives are going to be two negative infinity symbols. As we got to the left, that end is down. And as we move to the right, so is that end. So this concludes our lesson on investigating the graph of f of x equals x to the nth power.